Hello students, welcome to my second video lesson. It is so weird to not be able to teach you guys face to face. Like I said in the other video, I miss you guys, and this COVID-19 is a pretty crazy situation. But anyway, let's do this lesson. Won't take very long. Okay, so we're going to talk about conduction, radiation, convection. We're also going to talk about how convection and conduction relate to natural and technological systems like cast iron pots. And we're going to talk about the particle model of matter, with particles in motion. So we'll jump to that one right now. So the particle model of matter is simply this. Everything is made up of these little spheres, basically called particles. And all particles are in motion. So the motion actually looks like this. Every particle is moving in a straight line, and it's spinning, and it's vibrating all at the same time. Okay, so there's like three types of energy. There's straight line energy, there's rotational energy, and vibrational energy. Anyway, so just imagine looking down at your laptop right now, and if you could zoom into the particles that make up the laptop, they're all doing that. Now, solids, of course, the particles are a lot closer together than gases and all of that stuff that you heard way back in elementary school. Okay, now let's talk about conduction. So conduction is the process by which heat is transferred, and here's the key, transferred due to direct contact. Particles colliding with other particles. So you see I have a burner over to the left there. Well, that gray bar represents the heating element on that burner and that stove. Okay, now we're going to put a blue pot on there. So this blue rectangle represents the blue pot, and notice the blue pot is touching the heating element. Okay, so now here is the heating element. Here's a particle in the heating element, and there's a particle in the pot. So when we turn on the heating element, the molecules start vibrating faster and faster, and because they're touching the pot, those particles start vibrating. So the one actually has direct contact with the other, and the faster they move, the hotter it's getting. So looks like that. So they just start going. Okay, so that is what conduction is. Pretty simple. Convection is a little different. Convection is fluids that are in motion. Now, when I say fluids, you might think liquids, but no. Fluids is not just liquids. Like water is a fluid, but air is a fluid. And so fluids move, air moves. Living in southern Alberta, you know air moves because you've been out in a Chinook before. Okay, so convection is the process by which heat is transferred because fluids move. Heat is moving because fluids are moving. Hot air is less dense than cold air because the hot particles are spread out a little further apart. Hot air rises, cold air falls. A convection current occurs as hot air rises and cold air rushes down to replace it. And this is what causes sea and land breezes. So by the sea, if you've ever been to the ocean, the sand gets hot in the sun. It heats up the air above it. That air rises, and then cold air from the ocean rushes in to replace it. Here's kind of a look at it here. So that's hot air. That's less dense. And there's cold air up above it. That's more dense. You can see that the blue is spaced together a little more closely. And then the hot air rises. And as that happens, the colder air has to come in to replace it. So it looks something like this. That is a convection current. There's a very cool video that I've included in the links. You should check that out because it shows convection like in real time. It's kind of cool. Okay, and then radiation. Basically, think of this as heat, which is going through empty space. It's not like in the first one where particles touch each other, and it's not in the second one. It's not involving fluids in motion. It's just heat from position A to position B, kind of through empty space. So heat transfers through space. It does not rely on any contact between the two objects. The energy that's lost is emitted as light, or EMR, electromagnetic radiation. We don't get too much into that in our course. Hot objects give off EMR, and EMR comes in a lot of different wavelengths, and the wavelengths are what you feel as heat when you sit by a fire. Okay, so there'll be a video link on my on the assignment page, but if you've ever roasted marshmallows, that's radiation. The fire transmits heat through what we quote empty space, and then that heat heats up your marshmallows. So you've all seen that, experienced that. Okay, there you go, boys and girls. Conduction, convection, radiation. There's an assignment to do, and it's a pretty easy one. So that's it. Thank you.